Hi, my name is Jake Audet. I'm going to be taking the chapter 29 through 30 test today, starting with A, which asks us to find the magnitude of the emotional EMF in the rod. I'm going to quickly draw the axis real quick. Put our X here. And put our isolated rod. I'm going to go right here. Spinning way down. Velocity equals 3.9 meters per second. We don't have our emotional EMF or our magnetic electric field. So the formula for emotional EMF is the magnetic field times length times velocity, which comes out to 2600 times the length, which 8 centimeters, times our velocity, which is 3.9. Okay. Quickly put that in my calculator. Which comes out to 1.87, or sorry, 0.187 velocity, or yeah, sorry. Yeah, okay. There we go. Moving on. Or not, sorry, not velocity, voltage, that's what I was looking for. 1.187 voltage. But moving on to B, it says, find the magnitude of the electric field produced in the rod. Okay. Find the electric field inside the rod. We're going to use the relation between motional EMF and electric field, which would be electric field equals emotional EMF over the length, and the emotional EMF is our electric field over our electric field length, and then or the magnetic field, the length, and the velocity over the length. But since we already have that, we're just going to throw the we're going to throw 0.187 over the length. 0.187. What was the length? Which gives us 2.34 voltage over meters. So right here we can fill this in and that in. Sorry. Okay, moving on to C. Find the direction of the electric field produced in the rod. Well, in the problem, the velocity is in the plus y direction, and the magnetic field is in the negative z direction. Plus y minus z, which only leaves us with our x, which would be negative. However, the magnetic field pushes charge left, which becomes the electric. The magnetic field pushes charge left, to which pushes the electric points to the right, making it positive. So it is plus x is our direction. Just making sure. Moving on to D. We are asked to find if the resistance of the circuit as a given instant, find the current in the circuit. Well, to find the current in the circuit, first, we're going to need the motional EMF, which is B length, which is the magnetic field times length times velocity. Then we're going to apply Ohm's law after getting that, because current equals EMF over resistance. So let me quickly plug these numbers in. Which gives 0.018 B, because we, and to show it, 0.05 times 2.4 times 0.150 gives that. So now we're going to plug it into the current formula, which is going to be I equals 0.018 over the resistance, which is 0.0200, which gives 0.9A, which is our resistance. I'm going to now draw the graph. Just, I wanted to do it first this time, just for me at least, but we have a rod going this way. I'm going to go like this. The velocity equals 2.4 meters per second. And we have a circuit running with the resistance right here. It's going this way. Okay, and I think that is it right now. We have a current, just found our current, 0.9A. And then the rod is 5 centimeters. But now it's asking us to find E. And E is asked to find the direction of the current around the circuit, and I am recording sure for right around the circuit, which the rod moves left, the magnetic field moves into its page, and therefore we have a negative X, and we have a plus Y, leaving us with Z, which should be a negative Z. Therefore, it's moving to the right. Therefore, clockwise. It's moving in a clockwise direction. Okay. Moving on to F. It's asking to find the magnitude of the induced EMF in the rod. Okay. Well, we're given our velocity vector equals 1.5 I plus 2J meters per second. Our magnetic field, okay, magnetic field, I plus 1.50, okay. And now we have to do the cross product, which is IJK over, okay, 1.0, 2, 0, negative 1.20, 0, 1.50. Okay, we're going to go here, here, and here. Okay, J is going to be, because J is negative, it would have been positive because it's J, it's 0.225 negative, and K going to just be K actually is just going to be 0. But all that matters, I think, the rod is on the, let me draw the graph real quickly just so I get a better understanding of this. Saying rod is here, and there. These are potentials. Okay, our velocity is here. Velocity right there. I'm going to put magnetic field up here. But since it lies only on the x-axis, we just use I. So, therefore, since we just do I, we just times it by the length. We do the emotional EMF equals I times length, which is 0.3 times length was 0.08 equals 0.024 voltage. And there you go. Awesome. All right. Moving on to G, which end of the rod, A or B, is at a higher potential? Try to leave room for H here. Well, because it's on the right, I'd imagine B is a higher potential. It's also moving to the right, I'd imagine, from what I'm looking at. Yeah. And now H. Find the speed of the rod. Okay. And then balance force. So we do force equals resistance, or not resistance, current times length times magnetic field. Since we don't have all that, we just can split up the current into EMF, which is EMF over resistance. But we also need force, but we need a velocity, so we just move it around to the force times resistance. We gotta square them, squared, and length squared. Now we just plug in, we use my calculator. Force is 600. Magnetic field. gives us 4.12 meters per second. Awesome. Well, that's our test right there. Thank you so much.